Hello guys, this is Prime Concept. Still on our vector analysis. In this video, I want to consider addition and subtraction of vectors. So firstly, we'll be looking at addition of vectors. Addition of vectors. Now, in our previous video, we analyzed and introduced the concept of vectors. We defined what a vector is. We said a vector is a quantity that has magnitude and also has direction. We looked at the symbols and representations of vectors. So very quickly, if you have not seen that video, do want to go back to my channel and watch that video. Subscribe so that you would also be notified when I post new videos. Thank you. Now, vector addition and subtraction is really very important. So how do we do additions in vector? It's very simple. So vectors are added by joining these vectors. Remember we said that vectors are represented by arrows like this. So when you see something like this is a vector, maybe vector A, this is a vector B. So this simply tells you that this vector is pointing in this direction, while this is pointing with this arrow. But the moment you remove this arrowhead, you can no longer tell the direction of this. If I remove this becomes a scalar. So what makes it a vector is the fact that it has an arrowhead. So this is called the head of this vector, while this point is called the tail of this vector. So this is head and this is tail. So take note of that. This is head and this point is tail of the vector. Head and this is what? Tail of the vector. So it's very important. So how do we add vectors? Vectors are added by joining them head to tail. You add two vectors by joining them head to tail, and then you join from the tail to the head of the next one. That becomes the addition. So let me show you, or let me write it first. Vectors are added by joining them head to tail. So this is very important. Now say I have two vectors. Say I have vector A, this is vector A, and then this is vector B. And I want to add these two vectors. Exam will give you question like this. Say add it up. Now say I have these two. I want to add these two vectors. I'll pick the head of A and join it to the tail of B. Or I'll pick the head of B, join to the tail of A. Any one of them would give you the correct result. And why will it give you correct result? I'll mention it after the addition. So let's start by picking the head of A and joining. So it means I'll just bring it down. So let's say this is my B. This is my B. I'll just drag A down, still in that direction. You can see A is facing like this, right? So I'll drag it in that direction. So this is vector A. So you can see that I've joined head to tail, right? Now, since I've done this, to get the sum of A and B, I'll then join from tail to the head of the other one. So this is this, and then my arrowhead will point from the tail to the head. So this is what you know as the addition or the resultant, so which I would call C. So what it means is that C is going to be the sum of A and B. And why is it true? Say you are at this point and you want to get to this point. You have three ways and two ways of doing that. You are at this point, you want to get to this point. You have two ways of doing that. It's either you move straight from this point to this point, or you go like this. You get to this point and then get to this point. In vector analysis, anytime you are moving in the direction of that arrowhead, you're moving in direction of the arrowhead or the vector, then it is considered positive. But the moment you start moving against it, it is considered negative. So my arrowhead is pointing forward. So if I move forward, is addition. If I move forward again, is addition. So the same thing, I'm here. If I move forward, it is addition. So moving from here to here, it is addition, which is C, positive, right? Yes. Now C is equal to If I move from here to here, it's positive A, which is forward. I don't have to write it. And if you move from here to here, it's also positive B. So it means that your addition C is actually A plus B. So this is how you add vectors. Very simple. So you can have the value of A, have the value of B, and you are required to find the value of C. So it's simple. You can use cosine rule, but we're going to introduce a problem. But for now, we just want to see how to form the diagram. Now, let's do the other way around. Somebody may say, what if you join the head of B to the tail of A? What will it give us? The same thing. Trust me, to give you the same result. Now, let's do it. So, this is my A. Let's put our A. This is our A. This is our A pointing like this. This is our A, like you can see. Same way. Then I want to drag this and put, this is what I have. This is what I have. This is my B. And you see it. So I'll have to join from this tail to this head. That becomes my resultant. So this is my resultant, which is C. So you can see the same thing, just that this is flipped, or this is flip of that. So it's the same result. So this is also going to give us, assuming you are here and you want to get to this point, you move straight in the direction of that arrow. So you call it C. Or you decide to go this way, you can go this, which is actually going to be this to this is B, plus this to this is what? A. So it's going to be the same thing. This quickly brings us to something you need to know, that vector addition is commutative. Is commutative. What does it mean? It means that A plus B is actually the same as B plus what? A. So for vector addition, the same thing you have known for normal addition. For vector addition, it is also what? Commutative, which simply means that A plus B is the same as what? B plus A. So that is one thing you should know for vector addition. Also, second point I want you to note is that vector addition is also associative. So it is associative. Vector addition is what? Associative, which simply means that if you have A plus B plus C, this is same thing as A plus B plus C. So this is associative. You can still mix them differently. So, but this is what it means. If you add this first before adding to this, to give you the same result as adding this first before adding to this, and so on. So vector addition is commutative. Vector addition is what? Associative. So this is one thing you should know. Now, we're going to learn another method of vector addition. But before we learn that method, let's talk about vector subtraction, after which we can now look at another method of doing vector addition, which is very important. So vector subtraction, or subtraction of vectors. Subtraction of vectors. How do we subtract vectors? There are so many ways, but I'll stick to one. So vectors can be subtracted by joining them tail to tail. The vectors can be subtracted by joining them how? Tail to tail. So you subtract by joining tail to tail. So this is subtraction. So which means if I have, say, this is vector A, and then this is, let's say this is vector B, same way. Now, and I want to subtract these two vectors, I would subtract by joining them tail to tail. Let's do that and see what the result would be. So I'll have, this is my A, this is my B. I'll just drag it so that the tail comes to this point. So this is what I would have. This becomes my B. So you see that I've joined them tail to tail, right? Yes. The next thing I want to do what? Is to join from B. Since I'm subtracting B from A, I'll join from B to what? To A in this direction, right? Yes. So that I'll call this C, and C is the subtraction of B from A. So what do I have here? I have that C. Now say I'm at this point and I want to get to this point. I have two ways of doing that. I can go straight up, which is going to be C, because when you move here, what you have is C, which is equal to another way I can move is I would go like this. And you notice that when you move like this, you're moving against the arrow. So this becomes negative B because it is against the arrow. So you have negative B. And when you come here, you move to this point, which is in favor of the arrow, which is plus A. So it means you can simply say that C is A minus what? B. So this is how you can subtract vectors. So this is how we can subtract vectors, right? By joining them tail to tail. Some other persons may decide not to say tail to tail. They may use another method, which I really don't prefer, but is still correct. They can tell you that you can join the head of B to the tail of A, right? Yes, and how do you do that? Since you have your B facing this way, I can do it again. Let me rub this so I'll show you the other way. But this is the method I'll be using throughout my video. Now, they can say you want to subtract B from A. So what you do is you join the tail, the head of B to the tail of A. And when you do that, it means that you have reversed B. You've reversed B, so you have it as negative. Now, this is my A. So if I join this to this, I would have something like this. Then this becomes negative B because I've reversed the direction. B is forward, but for me to join the head of B to the tail of A means I have reversed it, so it has to be negative B, right? Yes. Now the next thing I want to do is to join in this way. And this becomes my C. So it's still going to give us same result. Now, assuming that you are here and you want to get to this point, if you move forward, you have C, which is equal to, if you move this way, you're moving in the direction of this arrow, which is already negative B. Then you move this way, you have plus A. So which still means that C is equal to A minus B. So any one of them would give you same result, but I prefer to say when you're subtracting vectors, you just join them tail to what? Tail, and then you connect. That is your result. So this is the subtraction of one vector from another vector. Please, very importantly, I want you to note that vector subtraction is not commutative. Vector subtraction is not commutative. What does it mean? It means that A minus B is not equal to B minus A. So it is not commutative, unlike in addition, where A plus B equals B plus A. For subtraction is not commutative. So A minus B is not the same as B minus A. So please take note of that. So I believe this is clear to you. Then finally, before we draw this video to an end, we're going to solve a problem or want to introduce another method of vector addition, which is what we know as Parallelogram's law. Parallelogram's law of vector. Parallelogram's law of vector. Parallelogram's law of vector is another law or is another method that is used in vector addition. So it's a method that is used for vector addition. So you should know it is used for vector addition. That's Parallelogram's law of vector. That is first thing you want to know. Now, can we state this law? Yes, so I will state it. This law says that if the two sides of a parallelogram, represent two vectors in magnitude and direction, then the diagonal drawn from their point of intersection would represent the resultant of these vectors in magnitude and direction. So let me write it. If the two sides of a parallelogram represents two vectors in magnitude and direction, then the diagonal drawn from their points of intersection represents the resultant in magnitude and direction. So that is just it. It looks long, but it's simple. It's not something to cram. So from the diagram, I'm going to explain so that you would understand it. Now, so how do we draw a parallelogram? Remember, a parallelogram has two equal opposite sides. For a parallelogram, two sides are equal. Two opposite sides are equal, and those two opposite sides are also parallel. So that is a parallelogram. Just the opposite sides are equal. If all the sides are equal and parallel to each other, then it becomes a what? It becomes a what? A rhombus. So that is different. But for a parallelogram, two opposite sides are parallel and they are also equal. Now this is it. So I have something like this. Because I'm not drawing to scale, my hand may not be very straight, but this is it. So this is a parallelogram. So this side is parallel to this side and they are also equal. Same way, this side is parallel to this side and they are also equal. So that is a parallelogram. The opposite sides are parallel and the opposite sides are equal. So that is parallelogram. Now, this parallelogram's law of vector is saying that if the two sides of a parallelogram, which is this side and this side, represents two different vectors. So let's say this is vector A and this is vector B. So it means that if these two sides represent two vectors in magnitude and in direction, it means that this is the direction of this and this is the direction of this. Then the diagonal drawn from their point of intersection, this is their point of intersection. If I draw a diagonal from their point of intersection, that diagonal will represent their resultant. So it means that the resultant of A and B, remember, let's call this theta, the angle between A and B. Then if I draw the diagonal, then I'll call this, should I call it C now? Okay, let's call it C. So it means that C is the resultant of what? A and B, or you can say C is the addition of A and B. Now, what is one of the things we know for parallelogram? We know that the opposite sides are equal. So if this is A, this side is also A. If this length is B, this length is also B, right? Yes. Now, also, we can still see clearly that if I extend this line, if I produce this line, you would see that this angle, which is theta, is actually corresponding to this angle. So here would also be theta. And if this place is theta by corresponding angle, then it means that I can get this angle. And this angle here is going to be 180 minus theta, because this is angle on a straight line. So that is going to be 180 minus theta. Now I can quickly apply cosine rule. I would show you the difference between cosine rule and parallelograms rule. They are not the same. I would show you the difference. You're already familiar with cosine rule. Now, I have this length, which is B. I have this length, which is A. And I have this length, which is C. And the angle that faces C is this, right? So I can use cosine rule. And from cosine rule, I would arrive at parallelograms rule. So according to cosine rule, C, which is the resultant, I'll have that C squared would be equal to A squared plus B squared minus 2ab, then cos 180 minus theta as the angle that faces the resultant. What you have like this now is cosine rule. Is what? Cosine rule. Cosine rule considers the angle facing the resultant, which is 180 minus theta. That's the angle facing the resultant. I would write it as a point for you to note. Cosine rule considers the angle facing the resultant. That's cosine rule. But parallelograms rule, on the other hand, considers the angle between the two vectors. The angle between vector A and B is what? Theta, which I'm still going to derive. Now, from what we know from our normal trigonometry, cos 180 minus theta. You'll also know that cos 180 minus theta is actually same as minus cos theta. If you use compound angle, you get this. That's to say cos A minus B equals cos A cos B plus sine A sine B. If you use that concept, you get this result I've written there, at cos 180 minus theta is same as minus theta. So if I go back and replace this cos 180 minus theta with this, I would have this minus here would now affect this, it becomes plus. So I'll then have c squared equals a squared plus b squared. Then this minus, when I introduce, or let's still write minus 2ab into what? Now I'm replacing this with minus cos theta, so that I can say c squared equals a squared plus b squared. This minus, when it multiplies this, it becomes plus 2ab cos theta, where theta is angle between vector A and B. So this rule we have just gotten, this formula we have gotten, is known as parallelograms rule. So take note, while this one is cosine rule, this one is known as what? Parallelograms rule. So parallelograms rule considers the angle between vector A and B. Cosine rule considers the angle that faces the resultant. So these are two different things. So to buttress this point, I'm going to take one example and summarize this video with that example. So quickly, all right, so we have this very simple example to analyze. The question says two vectors P and Q are inclined at an angle of 60 degrees as shown in the figure below. Find the magnitude and direction of the resultant. So we have this. We want to find the magnitude of the resultant. So first, we'll see that we can convert this into a parallelogram, and that is how exam will come. They will not give you the parallelogram. So it is you that can draw and then be able to convert into a parallelogram and solve. Now let's see how we can convert this. So we have this, and then we have this as 30 Newton, and this is 40 Newton. So if I should extend this to a parallelogram, I would have something like this. So this is what I would have. So it means that my resultant is going to be this diagonal drawn, which I would call C, right? And then they give us the angle between 30 and 40 to be 60 degrees. So which simply means if I'm to use the parallelograms rule that we just derived, I don't even have to draw this diagram to be able to solve it. It's just to show you. Now I have that parallelograms rule is C squared equals A squared plus B squared plus 2AB cos theta, which is the angle between the two vectors. So I have that C squared is going to be, what is my A? My A is 30 squared plus B 40 squared plus 2 times 30 times 40 cos my space, okay, cos 60. Let me write it this way. So now I have that this is going to give me 30 square is 900 plus 40 square is 1600 plus this 2 times 3 is 6, 6 times 4 is 24, so 2400 cos 60. So I have now, how do you add this? Very simple. You add these two, which is going to give us 2500 plus 2400 cos 60. So I have, of course, in mathematics, you don't say 2500 plus 2400. You have to solve this first. So I have 2500 plus, so I will quickly say cos 60 times this, and cos 60 is 0.5. 0.5 times 2400 is going to be 1200. So this is going to be 2, that is 3700. So this is c squared. But what we're looking for is c. So it means that to find our c, we'll simply solve by removing the square from c. So say we want to find c, c would become the square root of 3700. So when we evaluate this square root, we'll then get our answer. So that is how we can solve for c. This is the magnitude of the vector. And you want to get the direction. The direction is actually this angle measured from the horizontal to where the resultant is. So this is the direction. So for us to find the direction, which I would call alpha, we can use any rule. Remember, this place is 30. So we can use any rule. Let's say we can use sine rule. For us to use sine rule, according to sine rule, we have that sine alpha. Okay, do we know any other angle? Now I know this angle. This angle is going to be 180 minus 60, which is 120. That's what this angle would be. So then I would compare this, okay? So I would say sine alpha divided by this. Sine alpha divided by the side that faces it, divided by 30 equals sine c, which is, sine 120 divided by the side facing it, c. So with this, I can find alpha. So that sine alpha becomes 30 times sine 120 divided by c. So I have, and we know c. C is actually what we got, root 3700, right? Yes. So with this, I would have that alpha is going to be sine inverse of 30 times sine 120 divided by root 3700. So once you evaluate this, the value you get for your alpha becomes the direction. So please bear with me. I didn't come with my calculator. I usually don't like to use scientific calculator. I like to do most of them from my head, but I'll get one for the sake of these videos. So evaluate this and then drop the answer in the comment section. So with this, we have come to the end of this part of the video. In my next video, I'll be analyzing resolution of vectors, after which we'll get into multiplication of vectors. We've done vector addition. Next, we'll look at how to resolve vectors. Then next, we'll look at multiplication of vectors. That becomes the end of vectors. So do well to subscribe so that you'll be updated when I post these videos. Thanks for watching my video, Prime Concept.